Objective: understand the following: elastic collisions, inelastic collisions, and conservation of momentum. Materials: dynamics carts, 2, Velcro and spring attachments for carts, and dynamic cart rail, if available. Please note, this is an observational experiment, and as a result, no calculations are performed. Well, what is conservation of momentum? The conservation of momentum is one of the fundamental principles of physics. Momentum of a system is conserved if and only if no forces act upon the objects in the system. Scenario 1. Simulated elastic collision. An elastic collision is one where two objects hit each other and bounce back just as fast. When an elastic collision does occur, the total speed of both objects before the collision is equal to the total speed of both objects after the collision. Procedure for each trial. 1. Place both dynamics carts on different sides of the dynamic cart rail. Make sure the springs on both carts are facing each other. 2. Lightly push one of the carts into the other. Mark your observation on the chart below. The cart cannot be pushed too fast or else too much energy will be lost. Note: you may also experiment with pushing both carts toward each other. 3. Reset the carts and push the carts with a different velocity. We will be in this experiment pushing both carts at each other. Please enjoy this demonstration of experiment 1. In this trial, the left cart was pushed with a greater magnitude of velocity than the right cart. However, after the collision, the left cart has a lower magnitude of velocity than the right cart. Please pause this video and discuss if momentum was conserved and if kinetic energy was conserved. In this trial, the right cart was pushed with a greater magnitude of velocity than the left cart. However, once they collide, the left cart had a greater magnitude of velocity than the right cart. Please pause this video and discuss if momentum was conserved and if kinetic energy was conserved. In this trial, the left cart and the right cart were pushed at the same magnitude of velocity and separated at the same magnitude of velocity. Please pause this video and discuss if momentum was conserved and if kinetic energy was conserved. Scenario 2. Perfectly inelastic collision. A perfectly inelastic collision is where both objects stick together after they collide. This causes kinetic energy to be lost due to friction, sound, heat, or deformation of the objects. Also, because the objects are moving together, they have the same final velocity. Procedure for each trial. 3. 1. In both dynamics carts on the rail, making sure that they stick together. 2. Push one cart lightly toward the other, which will be at rest. If they stick together, record your observation in the table below. If not, repeat the experiment until they do. Please enjoy this demonstration of experiment 2. In comparison to the initial velocity of the first cart, the two-cart system traveled at a lower magnitude of velocity. In comparison to the initial velocity of the first cart, the two-cart system traveled at a lower magnitude of velocity. In comparison to the initial velocity of the first cart, the two-cart system traveled at a lower magnitude of velocity. At this time, please pause this video and discuss with your classmates if kinetic energy was conserved in scenario 2. If so, explain why. At this time, please pause the video and copy this chart in your notebook. This sums up this online lab. Thank you for watching this online lab. See you next time.